Today we're going to talk about adding and subtracting radicals. Adding and subtracting radicals. We've been simplifying radicals, and we've been looking at single terms. Right? So, for example, 7 times the square root of x. Now, a single term could be very long. We might have something like 8x, y, z, square root of 5x, y, z. And that's still a single term. What makes it a single term is there's no addition or subtraction in it. Right? As long as we have just multiplication and division, we can have a single term. The second we put an addition in there, the subtraction, we then have 2 terms. So now we're going to move on to looking at 2 terms. We're looking at expressions. Okay, eventually we're going to start looking at equations with radicals in them. So that's an expression equaling another expression. Let's just take a look at this. 2 terms. If I have 7 square roots of x plus 9 square roots of x, I can simplify that by combining those 2 terms into 1 term. Anyone want to guess how I would do that in this case?
Would it be 16 times the square root of 2x?
Okay, good guess. We have 16. Let me show you what we're technically doing here. We're using the distributive property in reverse. So we're saying, if I pull out a square root of x, what do I have left in parentheses? Imagine this distributive property. The square root of x times what equals 7 square roots of x? What would I have to put here to get this? 7. Right? So the square root of x times 7 would equal 7 times the square root of x. Plus, what would I put here? 9. What is 7 plus 9? 16. So I'm just left with the square root of x times 16, or I can flip that around and say 16 square roots of x. So that's one way of thinking about it. But there's a much simpler way, which is just to think about when we added or combined like terms. What's 7x plus 9x? Well, we learned that that's just 16x, right? It's 16x for this same exact reason, but it's so natural at this point for you guys to add like terms together. You probably don't think of this at all, right? You just think, oh, 7 plus 9, 16x. Well, I technically have 7x plus 9x. Remember, x is a variable. X can be anything. X, in this case, is just the square root of x. That's confusing because I'm using x for both variables, but what if I said 7a plus 9a? That would still be 16a, right? Mm-hmm. But instead of a, I really have the square root of x. So I'm just like adding together like terms, as long as I have the same thing in the square root. Okay? Let's take a look at some examples. The thing that's going to be a little different about this is we will not always have variables. So for example, what if I had 2 square roots of 3 plus 4 square roots of 3? The first thing I check, do I have the same thing in my square root? The square root of 3 and the square root of 3. Yes, I do. So then, can I add these numbers? Can I add 4 and 2? Yeah, that would be 6. So I just have 6 square root of 3. I'll show you in a minute. What if I had this? 10 square roots of 2x plus 5 square roots of 2x. So again, first thing I check, do I have the same thing in my square root? Square root of 2x, square root of 2x. Yes, I do. Can I add the numbers in front? 10 plus 5?
Yeah.
15. So I've got 15 square roots of 2x. We can also subtract. So if I had something like 20 square roots of z minus 7 square roots of z. I just say, okay, square root of z, square root of z.
13 times
20 minus 7 is 13. What if I had this? What do you think I would do here? Perfect, that's the answer. Nothing. I would do nothing. There's
No
absolutely
solution.
nothing you can do with this because the square root of 2 and the square root of x are not the same. So I can't combine. I don't have like terms. It's like saying, what is x plus y? It's just x plus y. There's no solution. I'm not solving anything. It's just this is already as simplified as it can be. So this would be, right? I would just circle.
Wait, so on the homework, will we just rewrite that?
Yeah, you could just rewrite that same thing. Or you could just circle it.
Or could we just say ditto?
Ditto. That's fine with me. Ditto. That sounds great. Right? The instructions are to simplify. We're simplifying. There's nothing I can do to simplify this. So it is the answer. Right? Alright. But there are cases when you actually can add them even though they have different numbers in the square root at first. So what if I had something like this? 2 square roots of 20 plus 3 square roots of 5.
Would you?
Why can I add that? Yeah, I can simplify the square root of 20. The square root of 20, well 20 is 4 times 5. And I know the square root of 4 is 2. So the 5 is going to be left behind in the square root. And then I'm going to have 2 times 2. So I'll have 4 square roots of 5 plus 3 square roots of 5. Hey, those are the same. Now I can add them. So what would I get?
Oh, 7 times square root of 5.
7 times the square root of 5. What about something like this? 3 square roots of 20 plus 7 square roots of 45.
Did you break both of them down?
I don't think 45 is going to turn into 20, and I don't think 20 is going to turn into 45, but in this case I can actually simplify both of them. So what can I simplify the square root of 20 to?
4 and 5.
Again, we have 4 and 5. The 4 is a perfect square, so I've got 6 square roots of 5. What can I simplify the 45 to?
5 and 9.
9 and 5. 9 is a perfect square, so I've got 21 square roots of 5.
Oh, and then the answer would be 27.
So then my final answer is 27 square roots of 5. Exactly. Beautiful.
How do we know when to do that?
You would always do that. When they tell you to simplify, you're just looking for ways to simplify.
Because we added both of them.
6 plus 21. Oh. What was it?
The 21, I didn't see the
Oh. Okay. Let's do a couple practice questions. Alright. So what would be 3 square roots of 7 plus 9 square roots of 7? What would be 4 square roots of x plus 10 square roots of x? What would be 7 square roots of x plus 2. Actually, I'm going to change that. That was 6. Alright, go ahead and try those on your own. And let's see what we get. Put them in your notes. Well, the 4 is a fixed square. We can simplify it out. What is the square root? So we have 3 times 2. What is that? 3 times 2 is 6 square roots of x, and then we have 7.
Oh no, 38.
Wait a minute.
Okay, what's the first step you would do in this first one? Yeah, we just add 9 and 3. What do we get? 12 square roots of x. What do we do here? We just add 10 and 4 to get 14 square roots of x.
I said
What do we have to do here?
Ditto.
No,
Ditto, ditto.
wait, but no, wait,
You do nothing.
but you can do the simple form.
We can simplify the 4, can't we?
Yeah.
What's the square root of 4? 2. So then we've got 7 square roots of x plus 6 square roots of x.
Oh.
Oh. What can we do with that?
So we do what?
Just do what we've been doing. 13 square roots of x. Interesting. Okay. How about this one? What did you notice about those numbers?
You can simplify the 2 into 16 and 2,
Mm-hmm.
and then the other one into 25 and 2. And so then it would, the first one would be 8 times the square root of 2.
Okay. So 16 comes out as a 4, right? 2 times 4 is 8 square roots of 2 plus,
30 square roots of 2.
okay, 25. The square root of 25 is 5. 6 times 5 is 30 square roots of 2. So then that would equal 38. So you can see why we had to learn simplifying first, right? In order to add radicals, you sometimes have to simplify the radicals first. So make sure you've mastered that skill. If you feel like you still need some practice with that, let's ask some questions. Let's look at those. All right.